Okay.
Okay, now let's start. Yesterday I gave you an exercise to do. I don't know whether you managed to do it. You can just go there. A minute. A minute. I'm still going. Wait. Still have some challenges here. Okay. I don't know whether you can be able to see it. Can you? Can you be able to see what is there?
Yes. Morning,
Okay,
sir.
thank you. Morning, how are you? I gave you the exercise. Let me just scroll a bit. This exercise, okay? Then I ask you to go and do it. I give you a hint, which is this one. And I hope you managed to do it. Did you have any challenges? Did you have any challenges? Or is there anyone who calculated it? Is there anyone who managed to solve the problem? Is there anyone who tried to attempt it? Is there anyone who managed to do it? Guys?
Yes.
You managed to do it? Okay. Can I get the solution from you? Simple or simple number. Can just say simple or simple number here. Here's the element of a simple or simple value sometimes. You can just say simple values. Or simple or element in a simple. So obvious, the simple numbers is ranging from 1 up to what?
To 6.
To 6, okay, because you calculated the probability there. So 1 up to 6, so it's 3, 4, 5, and 6. What are the elements in a simple or simple values? It's 1, 2, that is the first one. The second one?
1, 3, 1, 4,
1, 2,
2, 3,
2,
2, 4, 3, 4.
What about the means? Simple mean?
1.5.
It's 1.5.
2.
2.0.
4.5. No, 2.5. 2.5. 2.5. 2.5.
Or 2.5.
Yeah. 3 and 3.5.
Any suggestion? 1.5 to 2.5, 2.5, 3.0, 3.5. Okay. What about the simple mean for each sample?
0.5.
0.5.
2.
2.
4.5. 0.5.
0.5.
2. and 0.5.
0.5. Let me see. 0.5, 2.5, 0.5, 4.5, 2.0. Yes, that's what I got. What about the variance of each sample mean?
0.125.
0.125.
0.5.
0.5.
0.125. No, 1.25.
Yes, 1.25. 1.125.
1.125. Yes, sorry.
Yes. The next one?
0.125.
Yes, 0.125. The next one?
0.5.
0.5. The next one?
0.125 again.
0.125. Okay, fine. That's what I got. What about the estimated variance of the estimated population mean?
I've got 2, 8,
2, 8,
18, 2,
18, 2,
8, 2.
8 and 2. Yes. What about the probabilities of each?
Each is 1 over 6, 1 over 6, 1 over 6, 1 over 6, 1 over
1
6.
over 6. All of them. 1 over 6. So this is what I wanted you to do. Very simple and straightforward, okay? For those who made mistake, please just go and rectify, okay? So now, I think today we have to do some exercises as well, as we are busy with simple random sampling. Okay, for those who are having the lecture notes, may you please go to page 15, example 3.5. Example 3.5, page 15. Let me just go there. Try to write it down. Okay. This example 3.5. According to my lecture notes, page 15. The lecture note. Okay. It says, suppose that a random sample of size n equal to 20. In other words, given information, if given the sample size of n, which is equal to 200, hospital accounts, those are the hospital accounts. Okay. Selected from the population size of n equal to 1,000. Okay. The sample mean of the accounts is found to be sample mean. Sample mean of account y bar is found to be it's in dollars, $94.22. Okay. And the sample variance is found to be the S squared is 445.21. Now the question says estimate. Let me just write it down. So it says estimate the average due. Estimate the average due for all 1,000 hospital account. And place a bound. A bound on the error of estimation. That is the question. Given the information there, sample mean, sample size, population size, sample variance. Then they want you to estimate the average due for all 1,000 hospital accounts. So the average due is what? You are estimating the population mean, isn't it? For all 1,000 hospital accounts, and then place a bound. So can you start doing it? So what do you want to find? Is this mu hat? Can you please find it for me? Or anyone who's having an idea on how to find that?
It's the same as Y bar.
Thank you very much. So mu hat is the same as Y bar. And you don't have to calculate it. It's given there. The same as Y bar, which is equal to what? $94.22. Okay. So this one you have already been given it. So what is left is to do what? Is to find a bound. Okay. Bound on the error of estimation for the estimated population mean. So can you do that? You start by finding the estimated variance of the
Yes,
estimated
sir.
population. Yes.
Is that mu hat, that one that you wrote?
Yes, mu hat is equal
Okay.
to Y bar. Then you have to find a bound, isn't it? B. Bound on the error of estimation used to estimate the estimated population mean. And before you find the bound, you're supposed to find the estimated variance, isn't it? Can you please try to calculate it?
Calculate what, sir?
The bound. Remember, the question says estimate the average done for all 1,000 hospital accounts, okay? And then you place a bound on the error of estimation. In other words, you have to find the estimated mean, which is given there. Then from there, you find a bound. And the bound is equal to what? 2, if you still recall, times the square root of the estimated var of Y bar. Because it's the estimated mean. So you just want to estimate the variance of the estimated population mean. And then from there, you find the bound. The bound is B equal to this one. So can you do that for me? So in other words, find the estimated variance of the estimated population mean, which is the estimated var of Y bar. Then later is then that you can find the bound B. And tell me the answer. Is it clear?
Yes, sir.
Okay, calculate.
It's 2,67.
The bound is what? Come again?
2,67.
That's correct. But anyway, you have to start by finding the estimated value, isn't it? Tell me the estimated value of y bar. It's what? It's n minus n over n, isn't it? Times simple variance divided by n. And here the answer, you find it what?
1.78.
1.78084, I think so.
Sir,
Yes.
are we using the estimated variance of y bar or not the
Yeah.
estimate?
Eh?
We are not going to
What?
use the population variance.
The question says estimate the average. Estimate the average is y bar, isn't it? Okay. So now here you have to find the estimated variance, not the variance. If it was the population, if they say, okay, calculate the average, you see that? If they said calculate the average, that means you'll be calculating mu, isn't it? Then here you'll be finding the var of what? Of y bar. You get the difference? So because there they said estimate the average. So you have to find y bar or mu hat. And then later you find the estimated variance of the estimated population mean, which is this one. So not this one. Not this one. Okay. After finding the estimated variance, then that you can find the what? The bound. The bound here, you said is what? Bound, you said is what? Can you repeat it again?
2.67.
2.67. That is your bound. So what you have been asked to calculate is the estimated mean, then estimated variance of the estimated population mean, then the bound. Okay, think it's clear. Now, if you're done with that one, actually you're supposed to do exercise example 3.5, then go to exercise 3.1, example 3.6, then example 3.7. Then we're done. So let's quickly go to exercise 3.1.
Okay, so before we go there, can I ask something?
Yes.
The question says, and place the bound on the error of the estimate. We just calculate the bound and leave it like that.
Hey, isn't that actually the first thing is to calculate or to estimate the average, which is a y bar, which we did, even though we
Yes.
didn't calculate what is given. Okay. Then later they said place a bound. To place a bound, you have to calculate it. Then it's what
There's
you
no
did.
way of writing it. We just calculate it and put it there.
Yes, that is what they were looking for. This is how to place a bound. Exercise 3.1. Okay, let me just scroll. Exercise 3.1. This one is page 16. Okay. So here they're saying this is a bit, yeah.
You said the variance of the estimate.
The estimated, no, it's
The
not the
estimate,
variance, the estimated variance of the
yeah, the
estimate.
estimated variance you said is
Yeah,
1.78084.
Yeah, what we got? We
But
got
what
different one. The different one.
is, I get a
What
different one.
what is your answer then?
It's 2.669.
2.669. How did you get it? Did you use the same formula?
Yes, I said the standard deviation, which is 445. It's
Standard
445
deviation.
divide. Yes, the simple standard deviation. There's variance. Then divide by
Standard
the
deviation or simple variance?
simple variance.
Oh,
Then
okay. It's what?
simple variance. Oh, I thought maybe you found the bound. Is the variance that one? Not
Yes. Then from there you find the bound. That answer is for the estimated variance. Okay. Then after finding it, there is then that you can find a bound. It's correct. So you can rectify your answer. Then you find that the correct answer is 1.78. Okay. Exercise 3.1 is the Beetle example. You have been given the observations there, which is 2, 3, 4, 2, 5, 6, 1, 2, 8, 2, 4, 5, 2, 11, 2, 40, 2, 0, 2, and 2, 6, 7. Those are the observations given. Okay. And the question says, number A, okay, it says, let me write it in the way they presented here. Estimate. Okay, number A, the population mean. That's number A. Oh, and population total. Population total and population variance. Let me do it in this way. And population variance. Number A, you have to estimate the population mean, population total, and population variance. That's number A. Number B, estimate the variance of new heads and the variance of tau heads. Okay, those are the questions. Number A, you have to estimate the population mean, population total, and population variance. Number B, you have to estimate the variance of the estimated population mean and the estimated variance of the estimated population total. Can you do that? Number A,
So
what is the answer for number? Yes.
on this question, we don't have the value of the big N.
Don't have the value of the big A. That's a good question. Yeah, let me see.
Is it not 8?
Oh, it can't be 8. It can't be 8. I think, okay, yes, he is right. I think this question has been taken somewhere. Can we go back and check? I think it's the question that has been taken somewhere. So it's the continuation. Let me just check. Yeah, we're supposed to have the population there. There's nowhere where we talked about the beetle here. Because they're saying it's a beetle example. Let me check. Beetle example.
So I think if
Yeah.
maybe this can be a population, then we take a sample from it.
It's not a population. That one is a sample. 8 is a
No,
sample. Okay. You know what?
I think page
The-
13.
This question, yes, you are right. This question is the continuation from page 13, example 3.4. Okay. They talk about the beetle there. And then if you check, they said to estimate the total number of beetles in an agricultural field, subdivide the field into 100 equal size units. So that means the population there is what? Coming from there, it's 100, isn't it?
100.
Yeah. So that one is a sample size. 8 is a sample size. It's not the population. Thank you very much for. But anyway, for those who were not aware, that is the continuation of example 3.4.
What's the population?
Unfortunately, we didn't do that one.
It says 100.
Yes,
Sure.
N is 100. So what is the population mean now? Estimated population mean. Our time is running out. We're left with 5 minutes. Is it 5 minutes? Or almost 6 minutes? What is the estimated population mean?
222,875.
222. How many twos?
Yeah,
There are how many?
222,875.
3 of them.
Yeah,
222,87. Let's write it into 3 decimal places. 7, 5. Like this.
yeah.
Okay. Everybody got it right?
So
Yes.
I got 17.83.
How did you get 17?
I think it's
The sum of the
17.83.
n
I got
over 1,000.
17.83.
Hmm?
The sample size is 1,000, right, sir?
Sample size.
No.
It's
Can be
100.
1,000.
Sorry.
8.
It's 100, right?
8.
Sample size.
Population
No,
size.
we're calculating the population mean, right?
It's
We are calculating the
estimated.
estimated population mean. That is what the question says. Estimate.
Oh, okay.
Hmm.
Thank you.
It's not the population mean, it's the estimated one. Covered, ne?
Yes, sir.
Okay. What about the estimated population total? Otherwise, cow head.
It's 222,875.
Wait, let me just write down. 2 what?
87,5.
87. 87.5. Okay, everybody got it right? And you know the appropriate formulas that you are supposed to apply, isn't it? Okay. What about the sample variance, which is the what? Oh, it's only 2. Oh yeah, the estimated population variance, which is the sample variance anyway. It's S squared.
I think so. It's 1932,696.
1932,
696.
696.
Uh,
Like this.
I can.
Myself, I got
Yeah.
something different. Myself,
So
I
are
got
we
6.
calculating?
Hmm?
Are we calculating
And
S
we are
squared
going
or sigma squared?
Come again, I can't hear you.
X squared.
Are we calculating
It's
S
a
squared or sigma squared?
S
It's X
squared,
squared.
which is the sample population mean.
So why are they saying
Yeah.
estimate population variance instead of sample
Hey,
variance?
if you estimate, you are estimating this. You are
All right.
estimating this, isn't it? And this is the same as what? It's not the true population variance. It's the estimated one. So it's sigma head squared, which is the same as S squared. Okay, did you get 19 or 1932.69296? All of you. Because here, I don't know whether it's me who made mistake. Here I got what? 657. I don't know. It's 1932.657. Which one is the correct one? Which one is correct here? Between this one.
Will say you are wrong.
I'm wrong.
Yes.
Okay, the correct one is this one. Everybody? Okay. So that means you agree. I think our time is up. Let's stop here, but let me just remind you that we were supposed to finish all those exercises. Exercise 3.1, example 3.6, and example 3.7. So please just go and try them. Because next Thursday, we're going to start with something new. Just go and do example 3.6 and example 3.7. Any question?